Hello everyone, welcome back to my channel. So in this video we will learn about electric field intensity due to surface charge density. Okay, so in my previous video I have explained you about line charge density. So okay, E bar due to line charge density, and now we'll consider due to surface charge density. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get notifications from my channel. Right, in order to find the electric field intensity due to surface charge density, we'll consider a surface charge. Okay, so I'll explain you slowly. Try to understand the concept here. So this is the surface charge. Okay, I'm considering here. So with surface charge density rho s. Okay, so on this I'm drawing you the coordinate systems, right? So x, y and z. Okay, and I'm taking this as origin and a point here on z axis as 0, 0, h. That is, the distance here is h. Okay, so I'm considering an arbitrary sheet here, ds bar. Okay, small arbitrary sheet. So same arbitrary sheet I'm considering towards the other end of origin. Okay, so the distance between them is same. So here the distance is rho, and here also the distance is rho, and phi is the angle made by this sheet. Okay, this sheet. Okay, so phi is the angle made by this, right? So I'm joining this also, the perpendicular I'm drawing here. Okay, I'm considering this as r bar. Okay, so finite element sheet I'm considering. So that element sheet to the point of interest, this is the point of interest, so I'm taking it as r bar. Right, understood? So this is the height of the point from origin. So that height means the distance from origin on z axis. On z axis, so it is at a distance of height h. Okay, so the point of interest is at a distance of h from the origin. Okay, so I'm considering this. This is what required for analysis. Okay, this is the only thing which you have considered. Understood everything? So I'm considering a sheet of charge and have drawn coordinate system, and I have taken a piece of charge. Okay, so small piece of charge, sheet of charge, a small sheet of charge on the both sides of origin. Okay, so what is the, whatever the distance is here, that is rho, and the distance here also the same, rho. And I have considered the distance of the point of interest to this arbitrarily chosen sheet of charge is r bar. Okay, so I'm taking this. Right, so what is dq in this case? Dq is equal to rho s ds, because we are considering sheet of charge here. Okay, so what is the unit of rho s? That is surface charge density. It is coulomb per meter square. Okay, so from the triangle, suppose I am taking it as A, the point I am considering here as A, and this is O, and this is your point of interest P. So from triangle AOP, and from the triangle AOP, that is this triangle. Okay, so AOP. Okay, I'll redraw this triangle. Okay, this is triangle AOP. This is A, this is P, and this is O. Okay, so in this direction rho is increasing, and this is r bar, and this is h. Okay, so how can we write h? How can we write? So AP bar is equal to AO bar plus OP bar. AO bar plus OP bar. Okay, so AO bar plus OP bar is equal to reverse direction, right? This is from triangle law of vectors. Triangle law of vectors. Third side must be taken in reverse direction so that it is equal to the sum of the two sides of the triangle. So what is AO bar? AO bar. AO bar is along OA, that is a rho. Its value is rho. So if you write in the form of vector form, so it will be rho A rho cap. But here, so in this direction from O to A, rho is increasing, right? From O to A in this direction, rho is increasing. But we are taking from A to O. When you consider in reverse direction, rho is decreasing. Rho is a decreasing function, right? So it may extend from origin, suppose 0 to 5. It is extending. Sorry. So it is extending from 0 to 5. Assume that it is extending from 0 to 5. Now we are taking from 5 to 0. So in the reverse direction, it is decreasing. So decrement is represented by minus rho. So that is why I am taking it as minus rho A rho cap plus H AZ cap, because it is along the rho here and this is along Z axis. Along Z axis, H into AZ is your R bar. Okay, understood? So very simple concept. If from O to A, rho is increasing, but from A to O, rho is decreasing. So I have taken a negative sign here. Understood? So R bar is minus rho A rho cap plus H into AZ cap. Okay, then R, that is modulus of R bar value, is root of rho square plus H square. Rho square plus H square. Right? In this case, what is the electric field intensity value? So Q by 4 pi epsilon naught R square into AR curve. This formula doesn't change for any charge density, whether it may be line charge density or surface charge density. The formula is same, but the value of Q changes. So in this case, what is Q? Q is equal to integral S rho S ds. So integral S rho S ds. So it will be rho S into ds by 4 pi epsilon naught R square into R bar by R. Okay, so integral of rho S ds into, what is R bar? R bar is this, minus rho A rho cap plus H into AZ cap divided by 4 pi epsilon naught. So R square into R becomes R cube, and R value is rho square plus H square. So rho square plus H square whole to the power of 3 by 2 we can write. So root is 1 by 2, whole cube is there, so you can write it as 3 into 1 by 2, that is equal to 3 by 2. Okay. So here if you observe, this is the main point, please listen carefully. So what is ds here? Ds, so it is along Z axis, so ds is rho d rho d phi. Rho d rho d phi AZ. So in the direction of Z we require, so it is ds is equal to rho d rho d phi AZ cap. Okay, so rho d rho d phi AZ cap. So I am substituting that here. Integral of rho S into ds is rho, because Z is the axis where this surface charge density is going to be existing, right? So in the place of ds, I am substituting with this rho d phi AZ cap dot minus rho A rho cap plus H into AZ cap divided by 4 pi epsilon naught into rho square plus H square whole to the power of 3 by 2. Okay, So az dot, so in this the first term az dot arrow cap is equal to 0. Okay, so this term totally becomes 0, and az cap is equal to 1. Okay, these are the basics of unit vectors which we have already discussed. So integral of what will happen, rho s into rho d rho d phi into h az cap, because this is the direction. So magnitude it is okay, but if you want to write in vector form, you have to write again az cap also, divided by 4 pi epsilon naught into rho square plus h square whole to the power of 3 by 2. Okay, so this is E bar. So this is the surface integral, right? So I'll take one more slide and continue from this point. Okay, so right, we have now got E bar as integral of s, okay, rho s rho d rho d phi h az cap divided by 4 pi epsilon naught into rho square plus h square whole to the power of 3 by 2. So we know that the limits of rho is from 0 to infinity. Okay, so this is what I have discussed you when I am discussing the first concept, that is about the cylindrical coordinate system, and phi extends from 0 to 2 pi. Phi extends from 0 to 2 pi. If you have not seen that video, please see that video. I have explained there clearly. Okay, right. So now integration is with respect to rho, and integration is also with respect to phi. The remaining terms, that is rho s, 4 pi epsilon naught and h, all these are constants, so you can write outside the integral. Rho s into h by 4 pi epsilon naught is a constant, you can write outside the integral. So integration is with respect to rho, so rho is equal to 0 to infinity rho d rho. Okay, I'm directly separating the integrals also. Okay, rho d rho divided by rho square plus h square whole to the power of 3 by 2, right? And integral 0 to phi is equal to 0 to 2 pi d phi into az cap. Okay, so I am dividing it into two integrals. So all the terms which consist of rho I am taking in this integral, and only term which consists of phi is d phi, so I am taking it in the second integral. Okay, so from this second integral, so integral of d phi is phi, right? So and substituting the limits, you'll get 0 to 2 pi, so its value is 2 pi. So I am taking this 2 pi also, this integral value is 2 pi, so I am writing this 2 pi also in the constant term. So E bar is equal to rho s into h into 2 pi divided by 4 pi epsilon naught into integral rho is equal to 0 to infinity rho divided by rho square plus h square whole to the power of 3 by 2 d rho. Okay, so 2 pi 2 times, right? So E bar is equal to rho s into h by 2 epsilon naught integral 0 to infinity rho by rho square plus h square whole to the power of 3 by 2 d rho. Okay, so let rho square plus h square is equal to some constant t. So then 2 rho d rho is equal to dt. So rho d rho becomes dt by 2. So we are considering rho, that is we are converting this integral in terms of rho into integral in terms of t. So limits also changes, right? When rho is equal to 0, then t is equal to h square. When rho is equal to infinity, then t is also equal to infinity, because rho square plus infinity is also equal to infinity. Okay, so E bar is equal to rho s into h by 2 epsilon naught into integral 0 to infinity. When rho is equal to 0, what is the value of t? T value is h square. When rho is equal to infinity, then t value is also equal to infinity, right? So rho d rho can be written as dt by 2 into rho square plus h square. Rho square plus h square is t, so it will be t power 3 by 2. So this 2 is also a constant, you can write outside the integration. So rho s by h by 4 epsilon naught, it becomes 2 into 2 epsilon naught is 4 epsilon naught. So integral h square to infinity, so this will be t power minus 3 by 2 dt. Okay, so we know that integral of x power n is x power n plus 1 by n plus 1. Okay, this is of the same form. So E bar is equal to rho s into h by 4 epsilon naught into, now tell me, t power minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1. Limits are from h square to infinity. So E bar is equal to rho s into h by 4 epsilon naught. So az cap will be there. Everywhere az cap is there. Okay. So everywhere you have to write az cap. I forgot to write here. Into. So this becomes t power minus 1 by 2 divided by minus 1 by 2. Limits are from h square to infinity. So this becomes minus 2 when it goes to numerator. So minus 2 rho s into h by 4 epsilon naught, right? So I'm substituting the limits. So when you substitute this value, this becomes t power minus 1 by 2. T power minus 1 by 2 is infinity whole power minus 1 by 2 minus h square whole to the power of minus 1 by 2. So infinity whole power minus 1 by 2 is 1 by infinity. We can write it as 1 by infinity whole power 1 by 2. So it will be 1 by infinity. 1 by infinity is 0. So minus 2 rho s into h by 4 epsilon naught into, so this term is 0 because it becomes 1 by infinity. 1 by infinity is 0 minus, so 2 and 2 gets cancelled, so it will be h power minus 1. So it will be 2 rho s into h by 4 epsilon naught into 0 minus 1 by h. Okay, so there is a minus sign here. So minus into minus becomes plus, so it will become 2. So az cap will be there, don't forget to write. Okay, so 2 rho s into h by 4 epsilon naught into 1 by h. H gets cancelled, 2 1s are 2 2s are. So finally E bar, E becomes into az cap is there. So E bar becomes rho s, this is rho s divided by 2 epsilon naught into az cap. This is the formula for electric field intensity due to surface charge. Okay, so generally writing the formula, so E bar is equal to rho s by 2 epsilon naught into a n cap. This is the generalized formula. This is when we take the point on z axis. So on the from origin what we have taken, 0 0 0 to 0 0 h we have taken. So what is the distance here? So z is equal to minus h. When z is equal to minus h plane, so plane is z is equal to minus h plane. So when z is equal to minus h plane we have taken, so we are getting positive z. We are getting here positive z. That is normal, right? So when z is equal to minus h plane, so z is equal to minus negative plane, so we'll get a positive value of z. So that is why we have taken here a n cap. A n cap represents the normal unit vector. Okay, normal unit vector in the direction where this rho s is extending. Okay, so this plane is z is equal to minus h, so you'll get az. Suppose if you have z is equal to h plane, then what will be the formula? You can just change the formula as rho s by 2 epsilon naught into minus az cap, minus az cap. Okay, so you can just change the formula. So generalized formula is this one, rho s by 2 epsilon naught into an cap. So an cap is the unit normal vector. Okay, so in the direction of this rho s. Okay.